Hello, students. Good to see you all here today. I hope you're ready to have some fun today. We're going to have some fun doing some things to figure things out about your eyes and how we use your eyes to use the microscope. So, here we go. Let's get started with first where we left off yesterday. Hopefully, you've been quizzing yourself as to the identity of the different parts of the microscope. So, if I were to point to each of these different parts of the microscope, you should be able to identify what part that is pointing to. If you're not quite confident yet, keep studying. Keep studying the parts of the microscope. Please, please, please. But let us continue with today. We've got a whole list of things here we need to do, starting with some key points to remember. Some key points to remember. Now, you're going to have some time. Actually, I don't even think you have to write these down, because if you are observant, I believe I have already written these down for you in your book on page 31. So if you're looking at page 31, I have these written down for you. I'd like you to feel free to add some notes to that page if you'd like, but really pay attention to how we're going to be determining these things. First, we're going to be going back and forth between our notes here and our virtual lab. So let's talk about the dominant eye, shall we? So moving over to our virtual lab here, I'm going to have you do an activity from your tables. Now, we all have two eyeballs. Hopefully we all realize that, unless you've suffered some tragic accident, perhaps. We all have two eyes, which gives us binocular vision. But just like everything else, they're not really identical. There are some differences. Maybe you've heard that one of your legs is slightly longer than another, which makes you eventually walk into a circle if you're lost in the woods, which is why you should stay put if you're lost in the woods. But let's get back to the eyes. One of your eyes tends to be stronger than the other, and that stronger eye is called your dominant eye. Your dominant eye. You need to determine which of your two eyes is dominant, because it's that eye, whichever one it is, that you're going to use to look into the microscope. Now, some of you may know, if you are a hunter, maybe you are familiar with which eye you use through a scope, perhaps, to determine the best chances of bagging the big game. But regardless of your experience or knowledge of dominant eye, here's what I'd like everyone to do. Are you ready? Little activity. You're going to take both of your hands and put them an arm's length away from you. You're going to take your hands and form a triangle. Form a triangle with your two hands. See how your thumbs are together? Your thumbs are together and your fingers are together, and you're creating a triangle here. Illuminati. Don't do that. Okay. So here's a triangle. It's an arm's length away from you. Now listen carefully. This is what you're going to do. Keep both eyes open. Look at the front of the classroom, and you probably see a clock on the wall in the very front of the room. Move your hands with both eyes open. Move your hands and adjust the triangle so the triangle is touching the edges of the clock with both eyes open. You want to see the clock in the middle of that triangle. Then slowly move your hands closer to your face, keeping the clock in the middle of the triangle, and that triangle will go back to one of your eyeballs. In my case, it goes back to my left eye because my left eye is dominant. If your triangle came back to your right eye, it's because your right eye is dominant. One of your eyes is slightly stronger than the other, and that's the one that you're going to use to look through a microscope or other device like a telescope for that matter. Now, if that didn't work out too well for you, try it again. Make a triangle, arm's length away, okay? Keep the clock right in the middle, and here's another way of doing it. Keep the clock in the middle, blink your right eye. Open your right eye, blink your left eye. So you're blinking back and forth. One of your eyes, when it's open, will keep the clock in the middle of the triangle. The other eye, when it's open, the clock seems to magically disappear. The eye that keeps the clock in the middle is your dominant eye. Okay? So that is how you determine the dominant eye. Let's head back to our notes here. All right. Next point. Keep both eyes open. This might be the most challenging thing for you folks to do. Keeping both eyes open. When looking through a microscope, it's very common that whatever eye you're using to look through the microscope, the other one, you're going to be squinting and looking like this, thinking that you get a better view. That adds a lot of strain to your eyes. You should keep both eyes open. That's why you're using your dominant eye to look through the microscope. And it may take several times before you get the feel for it. My dominant eye is itching right now, probably from overuse. Or maybe I just have an eye boogie because I'm tired. Do I have an eye boogie in my eye? Okay, I think it's good. All right. The other eye should remain open. Your non-dominant eye should remain open because in the laboratory, you may be drawing what you see at the same time you're seeing it. So you kind of need both of your eyes open, and you're going to be kind of looking back and forth to draw what you see while you are looking at it. So although this might be a challenge, keep both eyes open. All right, for this next one, we're going to go back over to the lab here, all right? I want you to remember the alphabet, your A, B, C's. Whenever you get a microscope or return a microscope in the laboratory, remember your A, B, C's. And what I mean by that is this. Microscopes are very expensive. They are very expensive and very fragile. You don't want to be breaking a microscope. They're several $100s to replace. So the best way to carry a microscope is to grab it by the arm, hold it under the base, and carry it close. Arm, base, carry it close. Say that with me. Arm, base, carry it close. I said the arm, the base, and carry it close. I said the arm, the base, and carry it close. I said the arm, base, carry it close. The arm, the base, and carry it close. Once more, the arm, the base, and carry it close. That's how you carry a microscope. Remember your ABCs, arm, base, carry it close. That way you won't have any accidents. So make sure you remember your ABCs. All right. Next, holding a slide. When you hold slides like this one, all right, slides have specimens on them, or they will have a specimen on them if you are making a slide. In either case, you want to be looking at the specimen and not your grubby little arm finger oil, all right? Your little fingerprints, although the fingerprints are kind of cool to look at. But if the assignment is to look at a specimen of some other kind, you don't want to smudge the slide. So you always want to hold your slide by the sides. Hold it by the sides. Better yet, the side of the slide. Because if you hold it by the side of the slide, close by your side, not your neck, but your side down lower, you won't smudge the specimen. So don't ever, I'm going to show you what not to do. Don't ever grab a slide like this. No, 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 that's not good because you're smudging it all up. That's not good. Always hold it by the sides and the side of the slide. Okay? All right. Next. Low power, low light, then put it upside right. What does that mean? Well, I try to make these little mnemonics to help you remember things a little bit easier when we're in the lab. But you're always going to begin. In fact, let me go to a close-up view here. Let's go to the close-up view of our microscope. I mentioned to you before that when we begin looking at a specimen, let's say we are putting our slide of human blood. I want to look at the blood. Yes, master. Okay, so let's say we have a slide of some specimen on the stage, and we want to start looking at it. Remember what this is called? Objective lens. Should we start with the low power or the high power? Always start with the low power objective lens. Then you lower the body tube all the way down and it will stop. When you have the low power objective lens pointing down, you will not be able to turn it any further so that there's damage. However, if you have the high power objective lens pointing down and you lower the coarse adjustment knob, I'm not going to do it, but that coarse adjustment knob could be turned right in through the slide. And if you're working with a glass slide, that means shattered glass all over and a broken objective lens. And that's the most expensive part of a microscope. So you always start using your microscope with low power all the way down. But since you're not magnifying it all that much, relatively speaking, when your lamp is on, when you're illuminating it with the light, you always want to start with low power. You don't want to turn it on full blast because when you look through the eyepiece lens, you're going to be blinded by the light. And you don't want to be blinded. You want to be able to see the specimen on the stage. So always start low power, low light. Low power, low light. You'll have opportunity to crank it up later on. And that's our next point. The more you need to magnify, the more light you will need. So as we look back at our close-up view, let's say we've got our specimen in view right now under low power, and we want to zoom in. Well, as you zoom in to the medium and the high power, you're only going to be using the fine adjustment knob from that point on to get your image into focus. And you're going to be zooming into such a small area, you're going to have to illuminate it with more light. So there you can probably see I've turned the light up. You start with low power, low light. As you go up to high power, you have to add more light because you're getting to a much smaller area. And so in order to see your specimen, you'll have to have more light. That's all that means. That's all that means. All right. When you're done, you want to make sure that the light is off. Our microscopes, the ones that I've been showing you, have rechargeable batteries in their lamps. But if you keep the lamp off, or rather, if you keep the lamp on, it won't come back on. It'll stay off the next time you want to use it, unless you recharge it. So make sure the lamp is always off. Also, some of the older microscopes, if you leave the lamp on, it can get pretty hot, and that could be a fire hazard. So always turn the lamp off. Another thing I want to point out to you is this slopping away of your scope. Slop it away. What does slop it away mean? Well, let's check out the close-in view here again. Obviously, you will remove the slide from the stage and put it away correctly. The lamp will be off, and you want to slop away your scope. S-L-O-P. Store with the low objective power facing down. Is this the low power objective lens? Which means if somebody bumps into this, or gravity pulls the body tube down while in storage, damage could occur. We don't want damage to occur. So always put it back to the low objective lens and lower the body tube all the way. And notice there's plenty of room between the low power objective lens and the stage, so no damage will occur. And once you've confirmed that the lamp is off, the stage is replaced, and the low power objective lens is down, we can slop it away and we can store it with the low objective power down. And we put a cover on it to keep the dust off so that the lenses and the whole microscope will last much longer and will be nice and clean for the next time we need to use it. Okay, so here are some of the steps we follow when using a microscope. Study those steps before we move on. So let's just end this here right now. Let's go back here. So again, study these steps, the key points to remember, and then we'll be back for another activity. So for now, bye-bye.